What's up? Okay, in this video, Hermson teaches you how to solve equations with radicals. Okay, I mean, radicals are square roots. They can have cubed roots, but so forth, but we'll just stick to square roots in this video here. What I first want to do is just mark where the square root begins and ends, so from here to here. Now, before I worry about the square root, I have an operation outside. I have a minus 5, so I need to plus 5 plus 5. So that takes that side to 5. So I have the square root of 4x plus 1 equals 5. Okay, now I get rid of the square root. The opposite of a square root is the second power. So I go second power. And the square root now cancels, and I have the expression 4 times x plus 1. And 5 to the second power means 5 times 5, which is 25. Then I just get the x by itself. I'm minus 1. That's 24. I divide by 4, and that's 6. That's your answer for x, because 4 times 6 is 24, plus 1 is 25, square root of 25 is 5, minus 5 is 0. Okay, mark where the square root begins and ends. Now I have two operations outside the square root. I have a minus 1 and a times 4. We have to undo the minus or plus first. So 3 plus 1 is 4, but I know I have another operation. Okay, 3 plus 1 is 4, which I'm going to do, and I divide by 4. And 4 divided by 4 is 1, so the square root of x is equal to 1. So I add the 1, and then get that, and then divide by 4. Now the second power eliminates the square root, and then I have x, and then 1 to the second power is 1, and I'm there. Okay, my next problem. Let's mark where the square root begins and ends. Now this one doesn't have any operations outside of the square root. Okay, there's no plus or minus after the square root ends, and there's no multiplication at the beginning of the square root. So I can do my second power, and then 3x plus 4 is equal to 16, and then I just 3x plus 4 equals 16. Then I just proceed. I subtract 4, so 3x equals 12, and then I divide by 3, and x is equal to 4. Okay, mark where the square root begins and ends. Now, you only have one operation out there. It's a 4 in the front. There's no adding or subtracting after the square root. So I'm going to divide by this 4, remember, and that gives me 3. So the square root of 2x minus 1 is equal to 3. Now I can do my second power to cancel out the square root. Okay? So then 2x minus 1 is equal to 9, and I add 1, which is 10. 2 times x equals 10. And then divide both sides by 2, and x equals 5. Okay, now the next one, now things get a little more dicey. Okay, mark where your square root begins and ends. And I don't have a multiplication in front, and I don't have any adding or subtracting after the square root has ended. Okay, so I take both sides, I take that side to the second power, and I just have the expression negative 3x minus 5. Now over here it gets a little tricky. I don't have just a number, a value to the second power. I have an expression, so I parenthesize the expression. Now to parenthesize an expression, there are two terms. I would put a 1 in front of the x. It's a binomial. Bi means 2. Binomials to the second power. So that ends up being a trinomial, blank x squared plus blank x plus blank. Now, if you remember from a previous standard, the way to take a binomial to the second is just replicate it. You don't need to write this down, okay? And just watch, okay? So 1x times 1x. This is the long way, but I'm going to do it the short way, okay? You're going to want to do it the short way here because otherwise it convolutes the process. 3 times 1x and 3 times 3. So that's 1x to the second, that's 3x, that's 3x, and that's 9. So for x squared, I've got 1, and then 3 and 3 makes 6, and then 9. So that's what's going to go here, but that's kind of a long process. Okay, so here's what I do. I take 1 to the second power, that's 1, so that'll be 1x squared. Then I jump over here and I take the positive 3 to the second power, and that's 9. Okay. Now to find what goes here, what we do is take 2. You're going to take 2. Always start with 2 because you're doubling it. 2 times 1 times 3. Okay. And 2 times 1 times 3 is 6. Okay. So I take that to the second power, that's my x squared. 3 to the second power is 9. And then double 2, okay, times 1 times 3. Okay, now I got all these different x's. Some of them have, one of them's to the second and the other ones are not, so we can't combine the x's, okay? We have to get 2 answers, and I am going to need to factor the expression, but I need to get it set equal to 0. I need to set this so I can factor it. Set, factor. Okay, we're not set, okay? So I need 0 somewhere, okay? Now the side that doesn't have the x to the second power, we want to get 0 on that side. So we're going to add 3x, and that would be added to 6x. Then we add 5, and that would be added to 9, okay? So I have 1x to the second plus 9x, and then 9 plus 5 is 14, equals 0. Okay, now it's 3 terms, so you go to your GCFT. Okay, GCF. I don't need the negative, I don't need the x, and then 1, 9, and 14 is just 1, so that renders that irrelevant. Okay, so I take 1 times 14, that's 14 positive, so it's an adding, and I'm trying to add to get to positive 9, okay? 1 and 14, nope, 2 and 7, yep. So 9 positive means 7's positive, and the positive 14 means the signs have to be the same. Okay, so a is 1x to the second. So if a is 1, you can just get rid of it and rewrite it as x plus 2, x plus 7 equals 0. So f1, f2. So x plus 2 could equal 0, or x plus 7 could equal 0, and I just minus 2, that's negative 2, and I minus 7, and that's negative 7. Okay. So that's kind of a pain in the butt. Now let's go to the next one. You get the hang of it. Okay, mark where the square root begins and ends. I don't have an operation behind it or in front of it. Okay, so I go right to the second power, and I have 3x plus 13 because those just cancel. Now over here I have a binomial that I'm going to have to take to the second power. I'm going to put a 1 in front of there. Okay. I'm going to parenthesize that to the second, and I'm going to set up my trinomial here. So 1 to the second is 1. 5 to the second is 25. That goes here because you're taking 1 to the second and the x to the second, so the x to the second's already there. Okay, now to find the x, we take 2 times 1 times 5. That's 10. Okay. Now again, now I see we have 2 solutions to the equation. Okay, and I've got x second and x, okay? So I need to set the equation equal to 0 and then factor. Set equals 0 and then factor. Okay, now when you're setting it, you want the side without the x squared to have the 0, okay? Makes it easier that way. So I need to take away the 3x from the 10x and take away the 13 from the 25. So now I have 1x to the second. I've got 10 minus 3 is 7. 25 minus 13 is 12. Okay, so I see the three terms now. GCF and table. Okay, so the GCF, the negative is not needed, x is not needed, and then it's just 1, so we disregard that. Then I factor my use trinomial factoring procedure. 1 times 12, a times c is 12. So I'm looking for add to get 7 positive. Okay, 1 and 12, nope. 2 and 6 is 8. 3 and 8 is, or 3 and 4 is 7. Okay, so 7's plus, so I got plus 4, and the positive up there means the signs have to be the same, plus 3. A is again 1, so I can just rewrite that expression as the factors of x plus 3 times x plus 4 equals 0. F1, F2. So x plus 3 equals 0, x plus 4 equals 0, and then you got your two answers. So you get negative 3 and negative 4. Again, the reason that makes sense is because if x is negative 3, 3 times negative 3 would be 9, okay? And then 9 plus 13 is negative 9 plus 13 is 4. The square root of 4 is 2. And over here, 1 times negative 3 is negative 3 plus 5 is also 2, okay? Now, it also works with the negative 4 because 3 times negative 4 is 12 plus 13 is 1. Square root of 1 is 1, and 1 times negative 4 is negative 4, okay? And then plus 5 is 1, okay? So that's why there's two solutions. Okay, now the next one works a little bit different. Okay, so again, where's my square root begin and end? Right there, second power. And then I don't really have a binomial, okay? Just 2x, so I want to parenthesize that and just put 2x. There's no plus or minus. It's an expression, but it doesn't have a plus, doesn't have a minus. So that's kind of a game changer. So we'll have 20x minus 16. Now over here, I don't go blank x squared blank x blank because there's not that plus and minus. All I do is take the 2 to the second, which is 4, and then x to the second. Okay, now you got two answers. You've also got an x here that isn't to the second power, so you can't combine like terms with the x's. So you need to do this. You need to set equal to 0 and factor. Okay, obviously I'm not set because I don't see 0 anywhere. So I want to get the 0 on the side where the x squared is at. So that's the side I clear out. Now you're like, where's, I don't know where to put that because there's not an x. That's an x squared. Well, I just put it behind it and add 16. That goes behind that. Now I have my equation. 4x to the second, because you didn't have a binomial. It was only one term. So to square up one term expression, you just take the number to the second and the variable to the second. That's it. Okay, and that's 3 terms. And that would be greatest common factor and table. Okay, now we are going to have a GCF here. You don't need the negative, you don't need x, but 4, 20, and 16 all share a greatest common factor of 4. So I put 4 out, and then I go divide by 4. So that gives me 1x to the second minus 5x plus 4. Now ABC from here, 1 times 4 is 4. So that's an adding to get to 5 negative. That's 1 and 4. So negative 4, and that positive up there means the signs are the same. Okay. Now again, my A is just 1. It is not 4. It's now 1. So I can rewrite that expression as x minus 1 times x minus 4. Now this 4 right here I bring down, but since it doesn't have the 4 I've divided out, 4, I don't concern myself when I label the f's. Okay. X minus 1 equals 0, x minus 4 equals 0. So that's 1, and that's 4. So 1 and 4 are the solutions. Okay, last one I'm going to do. So again, where's the square root begin and end? Well, right there. So I don't have any operations I need to undo, which is a good thing because I don't have an actual value over there. So second, then second. So you're going to have x plus 7. Okay, now I do have, that's 2 terms. Okay, so it's going to be back to the parenthesizing it, and then blank x squared plus blank x plus blank. Now 1 to the second is 1, and 1 to the second is 1. Okay. All right, then I take 2 times 1 times 1. That would be 2. Okay. And that is how you take a binomial and square it. Okay, really pretty easy. Again, I keep going back to that because that was not a binomial. The only thing I had was 2x is 1 term. So I just square the 1 term with the number and its variable. But here, when I see a plus minus, that means it's 2 terms. Okay, so that is 2 solutions to the problem. And you have to set equal to 0 and factor. Okay. Okay, now remember, I want my 0 over where the x squared is not. Okay, I don't want to move the x squared. Minus 1x minus 7, I can minus 7 from there. So that gives me 1x to the second plus 1x minus 6 equals 0. So that's 3 terms. So that would be GCF and table. Negative is not needed. The x is not needed, and then you just have 1. So let's not do it. So I take positive 1 times negative 6. It's negative 6. So it's a minus trying to get to 1 positive. 1 and 6 isn't it, but 2 and 3 is it. Again, a is 1, okay, so I just need 2 parentheses. Oh yeah, by the way, I put signs. You're going to have plus 3. Negative means they're opposite, minus 2. So x minus 2, x plus 3 equals 0. Okay, so x minus 2 could equal 0, or x plus 3 could equal 0. So I add 2, and I get 2. Subtract 3, I get negative 3. Okay, these first 2 are pretty easy. Starts here, you need to minus 3 and then divide by 3, and then the second power takes you to where you need to be. So those are easy. It's over here where it gets a little dicey, okay?